Hello, welcome back once again. We have this interesting improper integral from MIT. The integral from 0 to infinity e to the power of negative x squared cosine of 3x cubed dx. So let's get started. This integral, let's call it I. And again, we have the cube of a cosine function. Then let us recall from this nice cosine identity. When it is cubed, that is the cosine of x cubed is equal to 3 by 4, the cosine of x plus 1 by 4, the cosine of 3x. So this awesomely applies that the cosine cubed of 3x is going to be equal to 3 by 4, the cosine of 3x, right? Then plus 1 by 4, the cosine of 9x. Is that not cool? So therefore, our target integral I is going to be equal to 3 by 4, the integral from 0 to infinity, right? E to the power of negative x squared. Hope I'm getting it right. Yes, of course. Then multiply by the cosine of 3x dx, and then plus 1 by 4, the integral from 0 to infinity, e to the power of negative x squared cosine of 9x, and then dx. Okay. So what the hell are we going to do here now? Okay, so this integral, remember that the cosine function is an even function, so it is same as dividing, that is 1 over 2 times the integral going from negative infinity to positive infinity. So this turns out to be 3/8. Then integral from negative infinity to positive infinity, e to the power of negative x squared cosine of 3x dx, and here is going to be plus 1 by 8, the integral from negative infinity to positive infinity, e to the negative x squared cosine of 9x, and then dx. Okay, this is nice. So now let's say we have the following function with parameter a, I of a, that this is equal to, say we have the integral from negative infinity to positive infinity of e to the negative x squared, and then cosine of ax, and then dx. So this is going to be equal to, but before that, let us recall something really nice. We know the cosine is the real part of e raised to the power of I theta, right? So with that help here, according to Euler, so this is going to be equal to, that's going to give us a real part, then integral from negative infinity to positive infinity, e to the negative x squared. And for the cosine of ax, that is going to be e to the power of iax, and then dx. And don't forget that we're interested in the real part, which is giving us the cosine of ax. So here, I of a is going to be equal to the real part, the integral from negative infinity to positive infinity. The same base, we add the exponents. That's giving us negative x squared plus, is that plus? Yeah. So plus iax. Is not that cool? And here we have our dx. So let's manipulate this exponential function. So here, I of a is equal to the real part, the integral from negative infinity to positive infinity. So here we're going to have e to the negative, then into bracket we have x squared. This is going to be negative aix. You get the idea? And then dx. So all we need to do is to complete the square of the quadratic expression in the brackets. So here is going to be x squared minus aix. So this is equal to the x is squared, right? Then minus 2 times x multiply by AI. And don't forget that we're going to divide this by 2. So what do we do? So we kindly divide this one here by 2. That is AI over 2. I don't mean the artificial intelligence, please. This is just A multiplied by the imaginary unit. So I don't want to mention I before it looks like we're dealing with AI here, okay? And here we're going to add the square of AI, oh God, still mention the name again, A times the imaginary unit divided by 2 whole squared. You get the idea? Don't forget we need to subtract that to balance this equation. So that becomes A multiplied by the imaginary unit divided by 2 whole squared. Remember we're trying to complete the square. So here x squared minus AIX is going to be equal to this is a perfect square from here, which is simply x minus a multiplied by I divided by 2 whole squared. And here is going to be plus a squared over 4. Square that well and you will realize. Okay, this is nice. So from here, I of a is going to be equal to the real part integral from negative infinity, right, to positive infinity, e to the negative. So what do we have? So we have x minus a multiplied by I divided by 2 whole squared plus a squared divided by 4. And here we have our dx. So open that big bracket with that negative sign. So here we have I of a is equal to the real part of integral from negative infinity to positive infinity. This is going to be e to the negative x minus a multiplied by I divided by 2 squared minus a squared over 4 and then dx. So from here, I of a is equal to the real part integral from negative infinity to positive infinity e to the negative x minus a multiplied by I over 2 whole squared, then multiply by e to the negative a squared by 4 and then dx. So put this outside because that looks like a constant, right? So get e to the negative a squared by 4, then the real part of integral from negative infinity to positive infinity e raised to the power of negative x minus ai over 2 whole squared and then dx. So time to make our nice use substitution we have been waiting for. Okay. So from here we're going to let x minus a multiplied by I over 2 equals t, differentiate both sides, we get dx is equal to dt. So here I of a is going to be equal to e to the negative a squared by 4 multiply the real part. The integral is going to be from negative infinity to positive infinity, right? So e to the negative t squared and then dt. And this is the well-known Gaussian integral, right? Which is equal to the square root of pi. So here I of a is equal to the real part of square root of pi is square root of pi. So therefore we just have the square root of pi multiplied by e raised to the power of negative a squared by 4. This is awesome. Okay, don't forget that I is equal to 3 by 4. The integral from, 3 by 8, I mean. So 3 by 8, the integral from negative infinity to positive infinity, e to the negative x squared, cosine of 3x dx, right? And then plus 1 by 4, integral from negative infinity to positive infinity, e to the negative x squared, cosine of 9x, and then dx. So for this part here, a is going to be equal to 3, and for this part here, a is going to be equal to 9. So this gives I is going to be equal to 3 by 8, right? multiplied by the square root of pi times e to the negative 3 squared is 9. We get 9 over 4. And then plus 1 by 8. Oh, don't forget this is 8 here. Don't forget that. So sorry for that. Then multiply by square root of pi. E raised to the power of negative 9 squared is 81 by 4. I think we're almost done. I think we're done. Not almost. So I is finally equal to square root of pi by 8. Then into bracket 3 times e raised to the power of negative 9 by 4 plus e raised to the power of negative 81 by 4. So this is our solution. Oh my God. Thank you for watching. Please kindly support the channel by subscribing. Also like, comment and share.